Hello everyone. So this is the part 2 of the linked list series. So in the earlier part we saw some basic concepts of the linked list, and in this part we will be discussing some of the problems related to the linked list. So one of the problem is finding the nth node from the end. So अगर ये हमारी लिंक लिस्ट है, so हमको लिंक लिस्ट के एंड से nth पोजीशन का नोड सर्च करना है. So basically if this is the end and we have to find the third node from the last, so what it will be? It will be first, second and third. So this will be the third node from the last. So how we can find it out? So there are basically three ways we will be discussing. So first way is the brute force solution. So in that case, what we have to do, we will just first find the length of the linked list, and then once we find the length, then we can easily find the nth position of the node from the beginning. So this is the formula. If m is the size of the linked list and n is the position from the last of the linked list that we have to find, so from the beginning, that node's position will be m minus n plus 1. So if we have to find the uh, third element from the uh, from the end of the linked list, so this is the example. So size of the linked list is 4 and we have to find the third element of the linked list from the end. So from the start, that position of the node will be 4 minus 3 plus 1, that is second. So this will be the second position from the start and third position from the end. So what will be the complexity of this algo? On to find the length of the linked list and on to traverse again to find the node from the beginning, and space complexity will be O1 because we did not use any extra space. So this is the code of the algo. Here we are finding out the size of the linked list by updating the count while moving our node to the next. By the time our current will be pointing to the null, counter will be having size of the linked list. So if this size of the linked list, that is count, is less than the position we have to find out from the end of the linked list, then we have to return the null, because size of the linked list is less than whatever position we have to find out from the end. So in that case we will have to return the null. So if this is not the case, then using the same formula, we will be finding out the position of the node from the beginning using count, that is the size of the linked list minus the position of the node from the end plus 1. So this will be giving us the position of the node from the beginning. Then we will be iterating from 1 to that position, and we will keep updating our current to the next of the linked list. By the time we will be moving that much steps, so our current pointer will be pointing to the node that we have to find out from the end. So in the earlier solution, our complexity was on, but we were traversing the linked list two times. So we have to more optimize it. So now we will be using the hashing table technique. So in that technique, we will be creating a hash map. So positions of the node we will be keeping as an keys in the hash map and addresses as an value in the hash map. So once we are done with the creation of the hash map, we can easily find out the size of the linked list as an size of the map, and using the same formula we can find out the position of the nth node from the beginning using that formula. So what will be the time complexity? On in creation of the hash map, but also on space complexity, because we are creating n elements in the hash map. So this is the code for the algo. Here we are preparing the map, we are traversing the linked list, and we are creating the map with the position and address of the nodes. So once the map is created, we will be checking if size of the map, that is size of the linked list, is less than the position we have to find out from the end. Then we will have to return the null, because in that case size of the linked list is lesser than the position we have to find out from the end. If this is not the case, then we can easily find the position of the node from the beginning using that formula, size of the linked list, that is map.size minus position that we have to find out from the end plus 1, and we will be fetching that value from the map directly in the O1 time complexity. So in the earlier solutions, our time complexity was On, also the space complexity was On. So we have to more optimize it. So how we can achieve it? We will be achieving it using the two pointers approach. So in this approach, we will be like having two pointers, end pointer and current pointer. So initially both our pointers will be pointing to the head, and then we will be moving our one of the pointers, that is the current pointer, to the steps to which we have to find out the last position of the node. So say we have to find out the third node from the last, so that will be first, second and third node. This is the third node from the last. So initially both our pointers will be pointing to head, and then we will be moving our one of the pointer, that is the current pointer, to three steps, so that it will be pointing to first, second and third. So it will be pointing to last node, and then we will be moving both our pointers by one step, that is one node. So after that our next pointer will be pointing to second node, and our last pointer will be having the null. So as we will check if this is the last node, so our end pointer will be pointing to the that node, third node from the last. So time complexity of this algo is On, because we are traversing only once throughout the linked list, and space complexity is also O1 because we did not use any extra space. So this is the code for the algo. Initially current pointer and end pointer both are pointing to the head. Then we are moving our current pointer n steps. So if we have to find out the third node from the end of the linked list, so we will be moving 3 steps and pointing that node to the current. So by that time our end pointer will be pointing to the head and current pointer will be pointing to the nth position of the node. Then we will be iterating rest of the linked list, and we will keep updating end pointer and current pointer by one step, that is one node, while we will be encountering null in the current pointer. So once our current pointer will be having null, so our end pointer will be pointing to the nth node from the end of the linked list. So say if we have to find out the second node from the last of the linked list, so initially both our pointers will be pointing to the head. Then we will be moving 2 steps to our current pointer, that is 1 and 2. Here our current pointer will be pointing and our end pointer will be pointing to head. Then we will iterate the rest of the linked list and keep moving both our pointers by one steps, that is one node at a time. So our end pointer will come here and our current pointer will come here, and we will check this position. Null in the current pointer? No, null is not in the current pointer. Then we will be moving end pointer one step, and our current pointer will be having null. Then we will be checking this condition. So current pointer now contains the null, so we will come out of this while loop, and our end pointer will be pointing to this node, that is the second node from the last position. So this is the best solution, because in that algo we have to iterate the linked list only once, that is the On time complexity. Also we did not use any extra space, so space complexity was also open. Thanks for watching.